Hey everyone. Can you guys hear me back there? Yeah? Okay, good. So if anyone was in the technology roadmap session, you might want to be somewhere else right now, because a huge chunk of that yesterday was to talk about our machine learning program at Engaging Networks. And I'm going to do a little bit more of a deep dive today than I did during the technology roadmap session. But if you were in the technology roadmap session, a good chunk of what you heard yesterday is going to be repeated today. Okay, good. All right. Okay, so my name is Covington. I'm the CEO, founder of Engaging Networks. And this session, again, is about the machine learning program that we are putting together and have been working on now very diligently for the last 14 months or so. And one of the things that obviously you can see up on the screen is that that's not the logo of Engaging Networks. So in fact, the machine learning, the sort of the data science portion of what we're doing within the machine learning program that we're putting together is actually being done through a separate company which has shared ownership with Engaging Networks, and it's called Accesible Intelligence. So it's just to kind of let you know that actually the data science part of the work that's being done is actually being done through a sister company, basically. So I'm going to spend a little bit of time just talking about initially I'm just going to talk a little bit about some of the concepts. So we hear a lot about artificial intelligence as a term. It's one of those really very loose terms that actually just means exactly what it says. It's essentially the ability for machines to do things like reason, navigate, etc., as we would do it as people. It's a concept that's been around for literally thousands of years. I mean, there's ancient Greek myths which talked about, I think it's Herodotus, one of the Greek gods anyway, who was endowed with the ability to actually create human-like creatures out of metal in his forge, etc. So the whole idea of being able to have machines effectively do things that we as human beings are able to do, like, again, reason, navigate, etc., has been around for a long time. So it's kind of like a very broad, high-level umbrella term that refers to any artificial intelligence. If you think about artificial intelligence, I used this example, yesterday. If you turned up basically in 1972 somewhere in Manhattan and you showed somebody, you had the ability to show them the smartphone that you now have in your purse or your bag or your pocket, and you told that person that actually you can use that smartphone to be able to figure out how to get from point A or from Manhattan to Brooklyn in the most efficient way possible, and as you go, get real-time updates in order to make changes to avoid traffic, etc., they would have certainly told you that was artificial intelligence. So like the goalposts for the broad term of artificial intelligence keep moving, because the more things that we develop that basically fall under that idea of artificial intelligence, the more demanding we become, our expectations are greater. And so artificial intelligence is a bit of a woolly term. It's kind of a broad kind of catch-all term. Machine learning is kind of an application of, this is the other term that you hear a lot, it's kind of an application of artificial intelligence. And as you can see here from the definition, it just basically provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So this is kind of like the software idea behind artificial intelligence in terms of machines learning, without being explicitly programmed. This, by the way, is what really is the catalyst for where we are now. There's like this huge explosion over the last 10 years of activity around artificial intelligence because of machine learning. Back in the 1950s, there was a conference in Dartmouth University where a whole bunch of specialists in artificial intelligence got together to have a conference. And they were really having that old approach to AI. They were trying to programmatically tell something, do this, if this, then do this, and if this, do that. And they really weren't making much progress because it's very hard to kind of codify rules to get machines to think. And so it's really the ability of machine learning, which essentially is now being able to create neural networks out of computers, the processing power that's now available, and the idea that essentially you can have machines learn from information, or in this case data, is really what has been the catalyst that's gotten this whole artificial intelligence movement going. And deep learning is is obviously a function of that. Deep learning is, again, it's like almost like a subset. Again, neural networks, server set up as neural networks, but it really is the idea that you're also using huge amounts of data to train machines to learn. So how are the machines learning? You're giving them a whole bunch of training data to be able to figure out what's going on within that data so that they can start doing things like predicting behavior. So that's what's really kind of been again, the jumpstart for all this stuff that's going on around artificial intelligence. It's basically the ability now to have processing power, to have huge amounts of data, and to basically use these approaches to artificial intelligence. When we think about it kind of in the nonprofit sector, most people think about applications of, and I'm just going to use machine learning because that's really the bulk of it. The idea that machine learning can be used to help nonprofits specifically on your service delivery. So, this is an example, for example, of a program in Africa where a charity wanted to make sure that they could be more effective at catching poachers of obviously protected animals. And so what they did was they started mapping the places where all these poachers essentially had recorded incidents. And then they got an application running an algorithm to troll through all that data to now start predicting behavior. And so now all of a sudden you've got an application that's up and running that's essentially an application that is an implementation of machine learning, which is now helping a charity to catch poachers who are essentially, killing game illegally in Africa. And that's often, like we think about disaster relief, what's the most efficient way to get disaster relief out to people, trying to map or predict areas where there might be human rights violations, all that kind of stuff. We think about service delivery. But you guys are marketers, you guys are digital executives, and so what you want to do is you want to figure out how is machine learning and how is AI going to help me do my job, because my job is actually fundraising, it's running, advocacy campaigns, it's managing data, it's looking at effective marketing and communications, etc. And the good news is that there is actually a lot that machine learning can do to help essentially make your jobs more efficient and more effective. And what we decided to do, the focus of anything when you talk about machine learning is all about problem solving. So how can we predict behavior to catch poachers? How can we figure out the best way to distribute aid during an emergency crisis in a particular part of the world? Whatever it is you're doing, machine learning is really about solving a problem. And so what are the problems that we have in the nonprofit sector as marketers, fundraisers, activists, et cetera? We decided to kind of think about, well, what are the problems that you guys are trying to cope with? Some of them are things like, for example, retaining donors for a longer period of time. Some of them are retaining activists for a longer period of time. Some of them might be getting an activist to become more active and actually increase their level of engagement. It might be getting a single donor to basically upsell into a monthly donor. It might be increasing someone's average gift for a single gift, et cetera. The interesting thing is that in the nonprofit world, organizations like yours all share those same challenges, those same, what we call use cases, effectively, or problems. So how do we solve them? And that's really what you guys are trying to do. Your objectives are to try and increase, for example, your file of monthly donors or total revenue generated through fundraising or to engage people more effectively. So machine learning starts with figuring out what is a problem, and we've identified four. One of them is retention of single donors, conversion rate of activists to donors, increasing a donation amount, and conversion of single donor to monthly donor. So we just picked four. We have about 40 that we set out there as use cases that are really the objective of our machine learning program. So everything that we're doing at Engaging Networks and with Accessible Intelligence is trying to focus on making sure that we can use and leverage machine learning and technology and thinking to solve your problems. And we're starting with those specific four. But there are lots of others, and I'm sure that you could probably come up with a lot of your own as well. So what is the heart of machine learning? So there's three boxes in this slide. And on the left side is data. So machine learning, and if you think about that subset of deep learning, it relies entirely on being able to have huge amounts of data. Because the data is essentially at the heart of what the applications are using to be able to predict behavior, right? They're learning from training data that already exists somewhere. And so the first thing you have to think about machine learning is what data do we have to be able to use machine learning, deep learning, to be able to come up with a solution for a specific use case. So it all starts with data. At Engaging Networks, we have a ton of data, but I'm going to talk about that in a minute. Once you actually have access to a lot of data, the middle box is the data science. That's where the magic happens. And none of us kind of knows what goes on. Data scientists do, but that whole area in that middle box is, okay, you now have applications, typically written in Python, that have embedded algorithms that are going through all that data, that training data, to essentially come up with a predictive model to solve the use case. The last box is the implementation. So if you think about it, if we said to you, here's the use case, it's about taking a single donor and trying to figure out the most effective way to market to that single donor to get them to become a monthly donor. If that's the use case, if that's the problem that you're trying to set and solve using machine learning, you've got data now that you can use, you've got the ability or the capacity to create the algorithms and embed them within applications. But if I told you now that actually Polly over there, as a single donor who's never made a monthly gift, which is not true, I'm sure, but Polly over there, she's been through this, and actually this whole magic that goes on in the middle, the data science, has now decided that the best way for Polly to become a monthly donor, or to be marketed to encourage her to become a monthly donor, is to deliver these kinds of emails, these kinds of content, etc. But you're not going to do that as you're not going to create a marketing program just for Polly and then another one just for Susan or for Nancy or for Priyanka. You're going to want to have some way to automate the implementation of this. So if you've got the data, you've got the data science working out to solve a use case, however it is now you want to, whatever that solution looks like, you need to automate the implementation of that. Otherwise, you're just basically creating more work for yourself. So those are the three buckets, and that's what my presentation is going to focus on, is basically looking at each of those three buckets. Does that make sense for everybody? The three kind of cornerstones of any machine learning program? Okay. So data. I'll just skip to the next slide. So data is essentially, we have lots of data. We have terabytes of data. We can know, for example, within Engaging Networks, how often you've sent an email to market to one of your supporters. We can tell which ones they've opened, which ones they've clicked through, if they've made donations in the past, if they've signed petitions, if they've taken part in other types of email advocacy campaigns, if they've joined an event, if they're a peer-to-peer fundraiser for you, if they've given a donation to another person who's basically been a fundraiser for you. So we have oodles of data. And it's very transactional. For example, we could say the best way, based on the data that we have access to, the best way, and Polly, I'm just going to use you for the next 40 minutes, I'm so sorry. But the best way now to kind of get Polly to become a monthly donor is to send her an email, 3 weeks after she makes her initial single donation, or 4 weeks afterwards, or 3 months afterwards, or whatever it happens to be. But that's a very transactional notion. That's a very kind of static idea. What you really want to do when you're talking about data is to be able to augment the data that we have with other types of data. And as far as we're concerned, one of the most important types of data that we're missing at the moment is contextual information. When Polly became a single donor, and we wanted, or someone else like Polly became a monthly donor and was upsold from a single donor to a monthly donor, what messaging did you give Polly? Did you give her, for example, a request for a monthly donation based on the same issue or topic that she became a single donor when you asked her to become a single donor? Did you ask her through an emergency appeal? Did you appeal to her sense of enthusiasm, optimism, hope, or did you basically shock her? And so therefore, is that the best way to now communicate with Polly to actually solve this whole issue? So the one big black box of data that we're in the process now of filling is essentially using content classification to understand what messaging, what tone, what emotion, what reading level, whether you're using images, what issues, what topics, what is it you're actually marketing to your supporters? Because if we have that data, then the machine learning program has some really interesting things that it can work on. It's not just transactional information, it's actually looking for the emotive response of your supporters to whatever it is you're marketing to them. Does that make sense? So that's one of the big things is basically that we're working on at the moment is essentially populating data to classify with values the content of what you are sending out to your supporters. There's other types of data. Obviously, we have constituent data where someone lives, for example, what country they're in, et cetera. There's offline data, which is not necessarily part of engaging networks. It is for some clients who import it. Other clients, it may not be. You've also got things like their social profile. You've got if you've got website, for example, if you've got information about what pages they're visiting. So there's a huge amount of data that you can potentially leverage. Our program is focusing on the transactional information that we have and this additional information that we're creating ourselves to classify content. When we decided to look at how we could classify content, we decided to look at some of the natural language processing tools that are available. So Google has one where you can literally just put in an email. So we put in this email from the Humane Society International, which is where Polly works. And we said, okay, well, what is Google going to come up with in terms of classifying this content? And it came up with some of the most bizarre things. Like, for example, it said things like for location, it identified ground as the location. So you can see that when you just use generic tools that have natural language processing capability, when you give them a nonprofit email like this one from HSI, it literally comes up with the most incredible nonsense. And so we didn't have any choice but to go and hire people through Accessible Intelligence to manually look at every single email that you've all sent. And by the way, you guys send a ton of email. Last year, I think altogether were about 68,000 emails that have to be classified now, basically in terms of their content. We're not doing that for any of your data other than the training data that we actually have permission to use from various clients. So here's what Google did, for example, but what you really want to know is, again, what was the urgency, or was there any sense of urgency? Where was the country, for example? What was the sentiment? Was it emotive, desperate, whatever, or, and breaking that down, what was the actual emotion itself that you're trying to provoke or evoke in the donor or prospective donor? Was it a fundraising ask versus advocacy, whatever? So the more that we know about classifying the content of what you're marketing to your supporters, the more data we can put into that first bucket. And so this is really a big focus. We've built an application which essentially can take all the feeds of the email content from Engaging Networks, the emails that you've built in Engaging Networks, pages you built in Engaging Networks, so we're doing both. It goes into the application, and we have someone named Melis, who's now started a couple of weeks ago, starting to classify the values for all of this email that we have permission to do it with. And the other one, there's another person actually that's joining next week named Hannah. So we have two people that are going to go out there now and classify all this content. The other thing that I want to mention is that when,
it's interesting. How do you know, you've got to provide like joy and happiness, or that. How do you, is it the words that are used in the body of the...
It's super tricky. So consistency is what's hard. Because if you have multiple people actually doing that content classification, someone's sense of what you're trying to evoke in the reader might be different than someone else's sense of what they're trying to evoke in the reader. So you need to create categories, of which we have about 40 altogether, but some of them are dependent. So if you select one, you might have another 2 or 3 categories that open up. We try to keep the value selections, the value options very simple. And that's what you do with machine learning, is you work with that. And then you kind of see how that goes, and maybe it's not good enough to actually look and find any decent patterns that it can then use to predict behavior. So you might have to go back and rethink it. We've ripped up and taken apart these categories 4 times already. So it's a process that is not just simple and straightforward, and you have to use essentially your response to the writing as a person. That's the irony of this, is that actually machine learning can't actually classify the content. So we have to actually manually, and there's companies out there that have armies of people that are doing nothing but creating databases for machine learning programs to actually run. So there's an industry out there of people doing jobs just like this. We decided to hire our own in-house staff, but there's a lot of third-party companies that you can give retainers to. So we have to break the back of this. So we have to basically get all the content classified for all the stuff that's kind of historically in there for the last 2 or 3 years. But once that's done, then we'll just basically be able to maintain it much more efficiently on a monthly basis. So this is a screen, a comp of what you will probably see at the end of November, again, if you have the data in Engaging Networks being classified. The data that we're classifying is going to be, for example, shown. So when you're looking at an email, there'll be an icon that you can click on to pull up this layer so you can see what values we've assigned for the various categories that we've attributed to the email. And then if you want to, it's not mandatory at all, but if you want to, you can then actually tell us, no, we think this value for this particular emotion is incorrect. So here's what we think it is. So we're going to learn whenever we have clients that basically push changes back to the classifications that we've attributed to their content. So this is actually data from the emails that we've done specifically from Humane Society International. I think we've done about 2,000 now. And for example, within the emotion category, 40% of them were really trying to evoke a sense of joy or happiness. Hope is 31%, fear was 6.6%, revulsion was 20.9%, and other was 0.5%, where we really couldn't find a classification, an appropriate value for it. So here, this is just one example of how you're looking at classifying content, and this is just an aggregate, obviously, presentation of some of that information. So that's all about data. And as we go, we hope to learn, we hope to add more data that can help us understand what's going on with your supporters, because the more data we have, the more efficient that the algorithms can be in basically finding some of those patterns and predicting behavior. This is a quote from Gordon Walsh, who's our data scientist based in London. The algorithm will classify supporters into groups that will likely be non-interpretable. So I'm kind of like, okay, that doesn't sound very helpful. So the first thing we do is that once you've got the database basically being set up, you're going to go in. The first part of the machine learning program is to then look at classifying people. So for example, if you go in, before you start creating algorithms to address a specific use case, you want to be able to go in and say, okay, everybody over here on this side of the room, you're in classification A. Everyone on this side of the room, you guys are all in classification B. You use what are called unsupervised algorithms to actually put you together in a group and you together in a group. The only thing that we can do is decide what databases the algorithms can look at and what data specifically they can look at. So for example, if we said to an algorithm, we want you to classify everybody, you guys know this is basically creating personas. This is what a lot of you already do, right? You guys go in and you kind of try and look at some data and put people into categories and call them personas. Classifications is the same idea, but it's being done by an algorithm. So it's being done, it's in an automated way. And that algorithm, it's put you guys in classification A, but we don't necessarily understand or can interpret why you're together. What you want to do is you want to say, well, actually, we don't want the algorithm to look at the email domain because you're not the same just because you've all got Gmail accounts and you've got all Hotmail accounts. So we have to tell the algorithms what data to look at so that actually it's coming up with classifications that are sensible based on someone's behavior, based on someone's characteristics, based on someone's interaction and engagement with content, for example. So the first thing you do is you basically run classifications. Typically, you're doing it through something called random forest. By the way, I presented this slide once at a conference in Toronto, and actually somebody put their hand up and asked me to explain them, and I was like, oh my goodness, I have no idea. But it's basically a decision tree, but it's a well-known algorithm. There's another one called nearest neighbor. This one's called random forest. But there's a bunch of unsupervised algorithms that, again, are creating these classifications. So the first step is to basically go and say, okay, you guys all belong together, you guys all belong together. We may not quite understand why you guys all belong together and you guys all belong together, but actually you're all in groups. Once we've done that, now we're looking at a use case. So the algorithms that are basically doing the classification are not trying to solve a problem for you. They're just trying to basically classify you based on similarities. When you look at use cases, you're looking for specific outcome metrics, upselling a single donor to monthly donor, for example. And so you're looking at using what are called clustered algorithms. And the issue is, the basic premise of this is that the algorithms are now saying, okay, everyone over there is in classification A. And everyone in classification A, we're now going to look at everyone who has been a single donor and who converted to a monthly donor. That's the training data. That's what we use to teach the algorithms to look for patterns. So we want everyone in classification A who's actually already successfully gone from a single donor to a recurring donor, a monthly donor, and we want to figure out what content, like, were they responding to the same issue that they responded to when they were a single donor. What was the length of time between their conversion, between a single donor and their first monthly gift? Where do they live? How many emails did they open in a year? I mean, it could be anything. There's huge amounts of data. And what we're looking at is saying, okay, let's take everyone, classification A, that's successfully gone from single to recurring donor, and that's the training data. So the algorithm is looking at all that data and trying to understand essentially where the patterns are. So it can now say when somebody else now comes into classification A as a single donor that's not a monthly donor, we now know what to actually market to that person. The reason that we know what to market to that person is because the algorithm has looked at the training data for everyone in classification A and has said, actually, here's the marketing stream that's the most effective way to get Polity to convert. Does that make sense? So that's the general approach of machine learning. And you do that on a use case by use case basis or a problem by problem basis. And the other thing is, it's important to note, is that the actual models that come out of the training data by these algorithms might also be more effective if they were done for nonprofits in a specific type of vertical and they're grouped together, or for the UK versus the US. So it's unlikely that we would just have a generic classification for everybody, regardless of the nonprofit that they actually belong to. The model will probably actually be broken down into subsets or different models using different subsets of training data. And I don't know that. The only way that you can figure that out is through trial and error. And that's what, again, machine learning is all about, is you basically set this up, you create the framework for all this work to happen, and then you start to implement it. So again, this is basically now we've got a new supporter, classification A. We now know what the communications plan or the marketing stream is for that individual. One of the ways that we actually work out now how these algorithms are going to be constructed for any specific use case is we do analytics initially. So we just literally look at the training data and we kind of go, hey, well, maybe is there a correlation between this and this? Because it helps us create more effective algorithms if we're actually pointing the algorithms to look at the right kind of data and make the right kind of associations. And so what we want to do is look at analytics. And so, for example, in this one set of data, we found that supporters with high levels of activism after they became a monthly donor have longer retention before they stop regular donation, for those that do drop off eventually, of around 40% longer. So that's a really interesting bit of information because it tells us something quite interesting about the correlation between level of activism and retention as a monthly donor. So now when we're building algorithms to upsell single donors to monthly donors, that bit of information is going to help us construct the application of the algorithm in a way which is going to be more effective and more efficient. Does that make sense? Yep.
Question, how are you measuring level of activism?
Well, and we wouldn't, I mean, there is actually a number behind this somewhere. I don't know what that is. I can probably get that for you. For us, it's going to look at like all the medians, averages, et cetera, and probably put them into like the top 25%, top 50%, bottom quintile, whatever. There's the data science behind this essentially is going to be grouping people into different levels of activism. But if you're asking me what the specific number is here, I have no idea. But if you've ever talked to a data scientist, you'll know that they don't fudge anything. They're just like, yeah, it's like.
Is it activism through the specific organization site, or?
In this case, it is, because I know this is for a single organization. And we just basically looked at the three advocacy transaction types that we have, which are tweet to target, email, messaging, advocacy, as well as petitions.
This is also a motivator for organizations to have more take action tools.
For sure.
For people to engage with.
Totally, yeah. But in the context of machine learning, it's just helping us understand how to build effective algorithms, essentially, to solve this use case, as it were. And this is the kind of the neat thing about it, is it would take people, it would take us years to be able to kind of work through all this data. That's the power of algorithms. So, for example, is it people that are more active? Is that just generally true, or is it true specifically of people who typically engage with a specific issue type? And if you look at, for example, the marketing stream that's going to come out, and this is kind of the really fun part. So now we're saying, okay, we've looked at the training data, and the algorithm is now going to say the best way to sell, to promote Polly becoming a monthly donor from a single donor because she's in classification A, is actually just to give her a bunch of good stewardship emails on the value of her initial gift and not to ask her for a recurring donation. Because that's the way people in classification A typically respond to those kind of appeals, is they like to know what's happening with their initial single gift before they upsell to a monthly gift. You guys in classification B, you're like, no, you give me an email after 2 weeks to a monthly donation, and actually that is the best way, that's the most efficient way to market to you guys in classification B, and classification C might be something completely different. So the point is, it's not a one-solution-fits-all approach. You're using the data science and the algorithms to actually be super intelligent about how you put people together that are similar, and then essentially you can come up with individualized marketing streams through the algorithms for each and every single use case. Does that make sense? Am I losing anyone? Nope? Okay. Once again, we've told now we've worked this out, the algorithm's done its magic. We now know that we have to send Polly 3 emails or whatever it is over the course of 2 months. We have to send Polly a certain type of content, for example, because we know the content was helpful in establishing patterns, and those patterns helped us now predict behavior, for example, for Polly and everybody else that is in classification A. So how do we now implement that? And that's one of the really fun things for us, is that Engaging Networks already has these fantastic tools that are set up for marketing automation. And so in this particular use case, what we're talking about is sending Polly a marketing stream. It might be multi-channel eventually, but right now we're just looking at email. So that's really the approach for that one. Another use case might be, what's the average gift? What's the suggested gift for someone to actually increase or maximize their total giving? And if you're looking at that, then that's not a marketing stream, that's just a number. So now you can basically say, okay, we want to actually insert an asking string with a suggested gift, and we want the algorithm that we've set up through machine learning to actually populate that content. In this case, though, we're looking at a marketing stream to convert someone from a single donor to becoming a monthly donor. So every use case will have a different output, but the first ones that we're looking at primarily are about how you market and what you market to people to actually solve that problem. If you're looking at, for example, donor retention over time, what is the best way to actually market to an existing donor so that they can actually now remain engaged and continue giving year in, year out? So every use case has its own implementation or integration, as the industry calls it. So what we're going to be doing is, for example, in this particular slide, you're going to see in Engaging Networks, when we launch our first use case, basically a list of all the use cases for which we have a machine learning application running. And you'll be able to turn them on or turn them off and prioritize them, because it's possible that Polly would qualify actually for more than one use case. She's a single donor, but also she wants to potentially become increased to a multiplier activist. So you've got to decide how it is you want to market to Polly, but not market to Polly for all use cases if she qualifies for all use cases. So you have to make sure that actually you're deciding what your priorities are and running them. And saying, for example, we'll provide you with tools to say, well, once you've done that with Polly, and Polly's now either successfully converted or hasn't converted, she might fall into another bucket for another use case, and then she can receive that marketing stream. So there's an issue here where you basically have to prioritize and decide which ones are most important, because it's quite likely that if you're trying to address a whole series of use cases, that someone might qualify for all of them, right? So if I drill down on one of these use cases, the first thing I'm going to see is all the classifications that have been created. In this case, we've just put up 4. There's likely to be well in excess of 4 classifications. And you'll be able to do some basic stuff on this, like reporting, et cetera. But you'll also see, and I'm not supposed to walk away from the mic, but anyway, you'll also see at the top where it says missing content. This is the really smart thing that I think we're doing, is that because we're doing the content classification, and we think that's where we're going to find a lot of patterns that will predict behavior, as soon as you put that data in to the machine learning, into the data science, you now need to therefore expect that on the other end, it's going to give you that relevance. It's going to say, because you've told us that actually you have all this data that's classified the content that Polly has responded to, we're now going to say what you should do is not just send an email, but send this email with this kind of approach, this image, a happy image, a joyful image, or only say, you know what, the best time to actually get everyone in classification A is when you do an emergency appeal. That's what they respond to. So don't ask for the monthly gift until, for example, there's an emergency appeal that you send. I don't know. I mean, this is what happens when you actually put this into the data science. But basically now you have to figure, okay, well, how am I going to actually create that content? if the machine learning process is completely automated and the marketing automation tools and engaging networks are sending out all this communication, they have to know what email to send. They have to have content that is now specific to everybody for this use case in classification A, B, C, and D, or E, F, G. So what we're doing is we're creating infrastructure. So this is basically showing you a very simple workflow for this particular use case. In this case, it's just like labels to say, yep, we just want to give you some visibility into it. So we're just basically saying, here is what the algorithm is suggesting is the marketing stream. So here's what the algorithm is sending to everybody in classification A. We're sending them this kind of content, this sort of frequency, et cetera, et cetera. So we want you to be able to see what is being recommended by the algorithm. But then again, you also now need the content library to be able to have all that content ready to go so that everyone in classification A, B, C, D, and E who needs certain types of content, because we know that that's part of the patterns in the data science that we've done, that the algorithm has picked up, we now need to be able to make sure that content is marketed to Pauly and everybody else in classification A when they qualify. So if we now need to make sure that that content is in place, we need to give you the space to create a content library within engaging networks that is just simply ready to go. And because we know that for a particular use case and for the marketing stream, for everyone within that use case in classification A, here are the types of emails with the content that you need to send them, we can flag that up for you and say, actually, you know what, you're missing this, and you're missing this. So you can't really run this until you create the content for everyone in classification A. So essentially, we can be smart about what we're doing. The other thing we can do is that when you're creating that content now within engaging networks, we can also say, by the way, here's an email that you sent before that basically is like 90% of this, but you just have to change the tone, or change the reading level, or make it shorter, or no image, or change the image because of the issue type or whatever. So we want to make sure that when you're creating a content library that we're actually giving you the tools to not only tell you what you're missing, but of the stuff that you're missing, which content you already have, which is like 90% of the way there. So you can just load that and then make some changes and save it. Does that make sense? So where are we? Right now, hang on. Hey. Sorry. Okay, so where are we? So we've set up the network infrastructure to get the data flows from engaging networks into accessible intelligence, into that environment. So that's the data that's needed. Right now, we have it set up in Amazon Web Services in an instance set up in Canada, and it's all anonymized. So there's no personal identifying information that would go into accessible intelligence. It's just basically all hashed based on the Oracle ID or email address, or or both. I'm not sure, one or the other actually. So the data flows have now been established between the network environment that we've set up, the network infrastructure, and we're also now working on the content classification. So in terms of data network stuff, we've actually been doing a lot of work building the application to classify the content, do all these things. In terms of the data science, we now have trial modeling data. We want more of it, so if you want your organizations to put trial modeling data in, let me know, because the more data we have, then the more interesting, the more work we can do. But then in the meantime, before we actually create the algorithms for each of these specific use cases, we're doing analytics to kind of just sort of, again, look for patterns within behavior by doing programmatic, essentially, analysis of data to be able to kind of let us know, hey, there is a correlation, there is a corroboration between this and this, or, you know what, statistically, there's nothing going on here between this and this. So it gives us a lot of really good insight in terms of how we want to build those algorithms. So that's something we've been doing now. We've created a whole bunch of analytics based on the data that we have. And then, of course, there's the implementation, which really hasn't started yet. Fortunately, the marketing automation piece already exists in engaging networks, and so there isn't a huge amount for us to do in terms of the implementation. We just need to do the implementation. It's really the content libraries that are going to be the key piece, that we have to create that infrastructure for the machine learning. Plus, we also need the ability for engaging networks to read the marketing streams coming out of accessible intelligence. So when it says, here's the best way to market to Pauly, we need accessible intelligence where the data science is being done, needs to communicate that to engaging networks. We'll use the marketing automation tools that we already have in place, and then just kind of tweak them a little bit and do a few other things in terms of the dashboard. But the implementation side, we've done comps, so we actually have started thinking about what this is going to look like, how it's going to work, but we haven't actually started any development on this. The first development that we're going to do is where you can actually see the content classification and the values that we've assigned, But again, if you guys want that, you have to let me know, because we're not going to do it unless you expressly tell us to put your data into the program. So unless you tell us to do it, you're not going to see anything, basically. And in terms of engaging networks versus accessible intelligence, I just wanted to be clear about this. So engaging networks obviously is where the data is initially. Accessible intelligence is really meant to be the engine for all the data science. And the reason we've set this up as a separate business and we've set it up with integrations with engaging networks is we want accessible intelligence to also provide that same data science services to organizations that may not use engaging networks, so that we have the ability for someone to actually put their data in, and we have to specify what data we need because it's all structured data for the most part. And then run the data science, and then potentially just sell them subscriptions through which they can automate, for example, the implementation of whatever use cases they want us to run. So that's why it's been set up separately. It's because we want the data science to happen, but we want to have it integrated for both implementation and also the data input, so that, again, it can be used for more than just engaging networks eventually. That make sense? From your point of view, if you go all engaging networks clients, it's completely seamless. It's, you don't see anything. You just basically literally have the content classification happening. You're seeing that content classification, the values basically within the dashboard, and then you essentially have the ability to create your content libraries and actually manage the use cases that are now available to you in your dashboard. So from your point of view, accessible intelligence is really just kind of like this other organization. It does require a legal agreement because they will be processing data and using that to basically to trial or train the algorithms. And so when we get to that point, right now we're still just trying to trial data and just kind of put all this together. But when it comes to production, though, then obviously you will need to have an agreement with Accessible Intelligence, just essentially saying that there's permission for you to actually access these services, et cetera. But I'm super excited about it because it's just a whole new world, and I think that we have done more work than anybody in the sector to really move this ahead. We've got great now infrastructure. We've got 4 people on the team. We've got a data scientist. We've got the project coordinator, a guy named Dwayne Raymond, Melis and Hannah, who are doing content classification. And when we get closer to production, we're going to hire a second data scientist. And we've got our own engineering team at Engaging Networks, obviously doing things like the APIs to get the data back and forth, et cetera. So we've done a lot of work over the last 14 months. We're still probably about I would say maybe 5 months away before we can actually get into production, something that would be completely automated for any one of these use cases. But we're getting really close. And again, I think that we're using a level of insight and intelligence in putting this together that is truly unique. So we're super excited about it because it's really going to be quite. There's huge quotes out there about people looking at the extent to which artificial intelligence in general and machine learning specifically are transforming the way digital works, and that's absolutely true. And so this needs to come to the nonprofit sector when it comes down to fundraisers, marketers, digital, anyone working in digital channels. So we're again super excited that we're really at the forefront of this. Questions? Yes.
So I have a question. In here you're talking about the classification of content,
Mm-hmm.
how you're sort of evaluating it, looking at it. So, how do you incorporate like how people are feeling that day or fatigue on issues? You know what I'm saying?
Yeah.
A lot of people we'll have, people generally will, react to, a scary photo of an injured animal or something like that. But there's that fatigue factor, like they see so many times they can turn it off,
Right.
or like external things that are happening in their life or how they're evolving, whatever
Yeah.
influences.
Yeah, you can't. We can't. We're limited to what data we have, right? So what's going on in someone's life? One of the things we have thought about is also maybe external news. So, for example, and there's a feed for that. There's actually a culture. There's a lot of other data sets we can eventually bring into this, but we're trying to essentially stand up the program on the basis of what we think is going to be relevant and is going to show patterns of behavior. But for example, if fatigue is an issue for someone who gets a particular email with a wounded animal or whatever, that in itself will create a pattern. Like that is something that the algorithms can understand and learn from, because they will see that people who typically respond to those types of emails, for example, and then they keep receiving them, because now we know you're sending to them because we've got the content classified. If they stop responding, that in itself becomes a pattern that the machines can use to then learn and understand, essentially, that that's a problem, and maybe you should try something else or do something else or whatever. But that's why you also do the analytics, because you then test that hypothesis. And you say, okay, let's look at all this content and see whether or not that actually bears out. In terms of how someone's feeling when they engage with it, obviously, that's the limitation of machine learning. If we don't have the data, then, whatever. But contextual stuff, if you can get the data, like what was going on that day, in that particular part of the world, or in that state, or locally, or nationally, or whatever, that is absolutely another data set that you can bring into this. And so what we're doing is we're not trying to, we're not trying to bring in every imaginable data set. We're trying to look at the transactional information, constituent data, and content is really at the focus of what we're trying to examine first. And then we can start layering in more data. And then, of course, you just retrain the model, right? You put in new data, the model gets retrained. The same thing happens when you have organizations that say, hey, I'd like to actually join the program. I'd like to actually benefit from these services. What do? Do they just run their data against the model, which is based on training data from aggregates of other organizations? Or do we add their data in and then rerun the model to basically retrain it? So now it includes the data from that new organization, or does that organization have enough data that actually they can run the model exclusively on their data? So there's lots of different options in terms of how the model can evolve, and there's also tons of stuff that has to be done to avoid building in bias as well, because it becomes a self-fulfilling prophecy. If you never change the model, and there's certain things you can do to be able to make sure you don't build in bias into these kinds of models, and part of that is also not just changing the training data, but also changing the models themselves, giving it new data to look at. For sure, absolutely. So, this is not like, oh, we've now trained this algorithm, and therefore we've got the model, and here it is. Depending on how long it takes, we could be rebuilding this model based on retraining it effectively every week. I'm not quite sure what the frequency will be, but we definitely want to be able to make sure the model is being updated based on and retrained, essentially. Does that answer your question? Yep. Any other questions? And thank you to Polly, by the way, because she's like she's like our maverick pioneer. She's been like, okay, yeah, I want to get into this. And the benefit, of course, to HSI now is that we're going to give them all the analytics we've been doing with their data, their anonymized data. So again, if you do, as an organization, want to be a part of this initial process where we're trialing data, please let me know, because we definitely are looking for organizations that want to do that, as well as the content classification as well. We'll be sending out emails, but if you want to let me know, just let me know. Any other questions? Are we out of time? Yeah, we're out of time. Okay. No other questions? All right, Brave New World. Very exciting.